Primitive data types. Programs and programming languages need to somehow encode information at the low level to represent different kinds of things to us at the high level. How is a number different from a name? To us, the human observer, they're obviously fundamentally different things. With a number, we can count up to it or down from it, or do all sorts of crazy maths. With a name, we can read or write it, or swap the letters around, or search through an article for it. But remember what we said about computers in our very first session. Smart, but also extremely stupid and stubborn. If we want a program that includes both, we somehow need to account for the differences between the two of them. This is where data types come in. Strings. Remember when we ran our very first print statement, "Hello World," how we enclosed our message in quotation marks. This is the syntax we use to represent strings. Strings are, quite simply, text. Whether a single character or an entire novel, they can be any length. They are most often used for human-readable information, such as a name or message, but can also be used for more abstract or formatted information, such as email addresses or phone numbers. Anything in speech marks will be interpreted by Python as one string. Important to note that, unlike brackets for mathematical and Boolean expressions, quotation marks can't be nested. There are no strings within strings, just one at the beginning and one at the end. If you need to include quotation marks in the string itself, you can preface each one with a backslash. This is what we call an escaped character. Alternatively, you can just replace the outer speech marks with a pair of apostrophes. Just be aware that then you'll need to escape any internal apostrophes. In Python, strings can have pretty much any character you want. Uppercase, lowercase, numbers, punctuation, and literally thousands of other characters, including alphabets from several languages, even many mathematical, scientific, even musical symbols. They can even encode special characters, such as line breaks, that is the new line when you press enter, and tab indents with their own special characters. An important trick with strings is concatenation, which means to attach two strings together. In Python, we can use addition to add two strings. Only we're not really adding them at all. A plus sign between two strings, and yes, they do both need to be strings, denotes concatenation. Two strings that will be joined together. Numbers. Integers versus floats. Next, a quick review of numbers in Python. Storing numbers in Python was one of the very first things we looked at, so it should already seem familiar. When we need a number, we just write one with a decimal point if we need it. Except that Python actually has two data types for representing numbers. The first is integers. Integers are strictly whole numbers, including 0 and negatives, which can be as large or as small as you need them to be, but strictly no decimals. 1 is an integer, -1 is an integer, 1.1 is not. Floats are, well, everything else. That is, decimals, fractions, even special numbers like pi or infinity. You can encode 2.5, -100.1, 7/11, even the square root of 3,975 using floats. This even includes numbers which we would think of as being whole, like 1.0, 2.0, etc. So does that mean all integers are also floats? Well, kind of, but not really. That is a true statement to make about how numbers work in the real world, but that's not how Python sees it. In Python, a data object can only be one type or another. If we write this, Python will see num as an integer, but if we write this, Python will see it as a float. It all depends on how we initially define it, whether we include that 0.0 or not. Worth noting is that we can still use all the same mathematical operators on both. Python will even convert integers to floats automatically when we need to. For instance, when division leaves us with a decimal. And yes, this does include equality too. So 1.0 equals 1 will be true. Booleans. Next, let's recap booleans. Booleans are their own data type in Python, i.e. either true or false, which in Python we write using the English words true and false, with a capital T and capital F respectively. Also, any Boolean expressions, which remember ultimately evaluate to either true or false, are included in the Boolean data type. That's really all there is to say. A quick word about none. One last big important data type we haven't discussed yet is none. None is nothing. Okay, no. Let's explain that in a little bit more detail. None is a value with its own data type, the none type. None is used to encode the absence of data. Surely we already do that with 0 or false. But no, 0 is still an integer with a definite value or a float if you do 0.0. False is still a Boolean, false and not true. The empty string is still a string. We still need a way to represent data that just isn't there or hasn't been defined yet. This is quite often used in data collections, which we're going to learn about next time, to represent empty or missing values. And this, of course, is what we end up actually using none for, to represent exactly this, missing or undefined data. Implicit casting and operators. These are the 4 most important data types in Python. To recap, strings, integers, floats, and booleans. As you can probably imagine, we have to use certain data types for certain things. For example, only numeric data, that is, our integers and floats, can be used for mathematical expressions. However, this does not mean that we can never convert between types. Converting from one data type to another is called casting. Python does a lot of casting automatically. A good example of this is division between integers, which we already discussed. This gives us, or can give us, a float. Print itself is actually another very good example. Technically, print only works with strings, which means anything else has to be cast to a string before it can be printed. Lucky for us, Python does this automatically. This kind of automatic type conversion is called implicit casting. Explicit casting is when we, the programmer, tell the program that we want to convert from one data type to another. We do this by calling the name of the type we want to convert to as a function, and we pass in the brackets whatever value we want to convert from. Worth noting is that you can't necessarily cast from anything into anything else. It depends on the data types and the data. You can convert any number into a string easily, but not every string can be converted back into a number. Attempting to convert data of one type into another where no such casted value exists gives us an error. Summary. Understanding data types is an essential part of learning programming. It helps us better understand how the program thinks, or perhaps more accurately, how it doesn't think, and how everything it does do needs to follow some kind of logic. It's out of these base data types that we can build more complex data structures and use them in programs of our own. With this in mind, we're ready to start exploring the rest of what programming has to offer.